Here we have the periodic table of elements. This is something you're going to want to become very familiar with for the rest of our chemistry course. This is going to serve as a basic introduction. We're not going to get in depth with the different groups or periods or trends. We're just going to introduce how to actually look at and interpret the periodic table. So first of all, these symbols right here, these are the element symbols. We're going to look at zoomed in versions in just a second, but they just represent the element itself. So you can just quickly glance at it and determine the element based on the symbol. Oftentimes the name of the element will be written at the top of each square in the periodic table, but on our periodic table in our room you'll notice that that is not the case. So you will want to become familiar with these different symbols. We're going to look at two zoomed in elements so that way you can see what each item means. So first we have carbon, which carbon was found right here on the periodic table, and then we have xenon, which is found down here on the periodic table. One of the first things you're going to want to know is how do I find different elements on the periodic table? Well, they are written in order of their atomic number. So that number that's found on the top is referred to as the atomic number. Now the atomic number, some things about the atomic number, we're going to make my writing a little bit smaller so we can fit more in here. Some things about the atomic number. Always a whole number, meaning it will never have a decimal. So the whole number with each element is always the atomic number. So always a whole number, and represents the number, the number of protons in an atom. So the atomic number is equal to the number of protons in an atom. So in carbon, carbon will have 6 protons every single time. Carbon will always have 6 protons. If the number of protons changes, then the element changes, because if we go to 7 protons, that means the atomic number will change. So if we went to 7 protons, it would change from carbon to nitrogen. So that's the atomic number. It represents the number of protons in an atom, and the last thing, and the number of electrons in a neutral atom. So we'll get more into neutral atoms versus ions and things later on, but just for your information now, atomic number, always a whole number, and is equal to the number of protons in an atom and the number of electrons in a neutral atom. So in a neutral atom of carbon, we would have 6 protons and 6 electrons. So that is what our atomic number does for us right there. Next, we'll look at the number on the bottom right here, our 12.011. This represents the mass number of an element. Now the mass number will be a decimal, so it'll typically be found on the bottom of the element right here, and it will typically be a decimal. You can always round though, that's important. So in this case, you would round this to 12. So we will typically always round the mass number, but just so you can find it, it is usually a decimal. And the mass number is useful because it tells us the mass of 1 mole, which we'll get into moles later, but 1 mole of that element. But it's also useful for our immediate purposes because when you do the mass number minus the atomic number, you get the number of neutrons that are in an atom. So the 3 different subatomic particles in an atom are protons, electrons, and neutrons, and this element on the periodic table tells us how many subatomic particles are in each element. So if we want to know the number of protons or electrons, we look right here at the atomic number, the whole number, and that tells us, hey, carbon has 6 protons and 6 electrons. If we want to know how many neutrons an atom has, we have to do the mass number minus the atomic number, and that will give us the number of neutrons. So in this situation, it's actually the same because we do 12 minus 6, and that gives us 6. So carbon would have 6 protons, 6 electrons, and 6 neutrons. So that is carbon right there. Let's look at xenon, and I want you to kind of do this yourself before I do it. So pause the video, identify how many protons are in xenon, how many electrons are in xenon, and how many neutrons are in xenon using the atomic number and the mass number, and then I will do the same. So hopefully you did that. Let's look right now. Let's identify first this is our atomic number. So circled in red right here, this is our atomic number. And again, that represents the number of protons and electrons. So that means xenon is going to have 54 protons and 54 electrons. Next, we want to identify our mass number. Our mass number is right here, 131.293. Now remember, it's a decimal, but you're going to want to round it. So we would round it down to 131. And then to solve for our number of neutrons, so neutrons equals, we'd have to do 131 minus 54, because you do mass number minus atomic number. So 131 minus 54 gives me 77. 77 neutrons in xenon. You got those correct. We're going to explore the periodic table today, and you'll get a chance to calculate these numbers of protons, electrons, and neutrons. Until next time, farewell.